Hello, my name is Faith Jean, and I am presenting Lab Report 2 for Introduction to Physics 2211, which covers the motion of a falling object. In this lab report, I will go through a brief introduction on the purpose of the lab, preliminary results, and key concepts related to the lab. Next, I will analyze the eraser's motion in Tracker. Next, I will discuss the coding that I used to make the computational models to simulate the real-life scenario. Next, I will compare the observed data to the predicted data from GlowScript. Next, I will go through what does this all mean and what if scenarios, and finally, I will conclude what the lab taught us. The purpose of this lab is to analyze the vertical motion of an object, being an eraser, to determine its position over time, and also to create two computational models that will simulate the real-life scenario. However, one graph will have gravity only, while the other will have gravity plus drag forces. And then we'll compare the effects of gravity alone versus gravity plus drag. The preliminary results showed that the computational model that incorporated gravity and drag forces were more similar to the observed results than the computational model that only incorporated gravity. Key concepts associated with this lab are Newton's second law, which states a force applied to an object at rest causes it to accelerate in the direction of the force, which is illustrated by the velocity update formula. When the net force on an object is not zero, the velocity can be increasing or decreasing. Other forces involved include the gravitational force, which is the force that attracts any two objects with mass, one typically being Earth, and this is depicted by negative mass times the gravity constant, and also drag force, which is the force acting opposite to the relative motion, which this can be illustrated by the proportionality constant for the magnitude of the drag force multiplied by the velocity squared. In this lab, I selected the eraser as the system, and the earth and the air the surroundings. As you can see, the eraser falls as an effect of gravity. I would like to note that my y-coordinates get more negative, as the coordinates in Tracker had the bottom of the picture being more negative than the beginning of the picture. This is the code I used to simulate the gravity-only computational model in GlowScript. I incorporated the system mass and the initial conditions, where the initial velocity is zero because the eraser was falling from rest. B is the proportionality constant for the magnitude of the drag force, which is zero because we are only modeling gravity right now. I also incorporated my time at the final position and the gravity equation because right now the net force is only gravity. And then I incorporated the momentum principle with the velocity update formula and position update formula in terms of how the eraser was falling. This is the code I used for the computational model simulating gravity plus drag. The only key differences between this model and the gravity-only model is that B now has a value 0.03 because there is now drag involved, and the net force now incorporates gravity plus drag. This graph shows the y position as a function of time for the observed data as well as the predicted data from GlowScript with the gravity-only computational model and the gravity plus drag computational model. As you can see, when we compare all three models, the recorded gravity plus drag model is most similar to the observed data because over time, the drag force competes with the gravity force, thus slowing down the motion of the object falling, making it more similar to the real-life observations. Gravity alone does not simulate the real-life scenario because there is not only gravity acting on an object. So what does this all mean? Terminal velocity is when the force of drag is equal and opposite to the force of gravity, making the net force zero and the velocity constant. In the gravity plus drag graph, the terminal velocity occurs around 0.3 seconds because the slope flattens out and the velocity is then constant afterwards. The graph with gravity only could not have a terminal velocity because drag is not incorporated. So what if the eraser was thrown down, thus having an initial velocity rather than falling from rest, having no initial velocity? Well, if the eraser was thrown down rather than falling at rest, the terminal velocity would occur sooner, at about 0.2 seconds rather than 0.3 seconds, because the object was thrown down, it reaches the terminal velocity faster. In conclusion, gravitational force and drag force, or air resistance, are at play in the motion of a falling object. Drag force counteracts gravity, making an object fall slower than if only gravity acted, and terminal velocity is a vector that incorporates gravity and drag forces. Thank you for your time.